right, everyone. Welcome to the wasmCloud community meeting for Wednesday, February 28th. Hey, get out of here. Today, we are going to be talking a lot about WRPC. We've got an agenda to start, which I'll be showing a couple components communicating with WRPC. And then we'll check in on progress to like a full initial MVP. And then, as usual, we will do our roadmap check-in. So, setting the stage for the demo, if you haven't seen WRPC before, or you want to understand what it is in the context of wasmCloud, WRPC is a protocol that allows components to communicate over a distributed network. Now, that's pretty high level and a little bit more in the realm or a little more biased with the view that wasmCloud is going to use WRPC for. But the TLDR is that the way that wasmCloud actors communicated over a distributed network, which is what we use NATs for before, was a protocol called wasmbus. So this protocol involved the WebAssembly guest talking to wasmCloud, basically handing it an invocation to send over a NATS message. This could be any type of invocation. It could be, hey, go send an HTTP request for me. Hey, capability provider, go interact with this database for me, things like that. But what WRPC is a whole replacement for the wasmbus protocol, where instead of doing very explicit guest host boundary things with an invocation, components are actually just able to call their imported functions, and we will send a representation of that invocation of an imported function over the wire. So if you're interested in learning a little bit more about what it means in a wasmCloud context, I would recommend this RFC, which was written by some super smart guy, whoever this is, that talks about how wasmCloud changes in terms of WRPC. And then I have another linked PR. If you search WRPC in the wasmCloud repository, you will find these. This one, written by an even smarter man in the wasmCloud org, really talks in depth about WRPC. Now, this one has a couple of pieces of information that are a little outdated now, just because keeping this one pretty large RFC up to spec takes more effort than just implementing it. But this really talks about how the protocol is designed. wasmCloud will be using this for NATs, but it's designed in a way that it can be implemented over HTTP, quick, et cetera, et cetera. So lots of information there. The TLDR is this is how components are going to be able to talk to each other. So if you're interested in kind of following along with some of this code, what I'm going to be showing today, feel free to take a look at this PR in the wasmCloud repo for updating the WRPC test. But what I want to, without further preamble, do is get into the what this test is and what it looks like to use WRPC. So this is an integration test in wasmCloud. I hope that this level of Zoom is acceptable. I'll do one more because why not? We have this one test that basically just sets the stage, sets up the infrastructure for wasmCloud. We start NATs, we start a wasmCloud host. Then we scale up two different wasmCloud or two different WebAssembly components. This one is called Pinger and this one is called Ponger. And then using our new interface links, which is how we dictate what place, what component to send these function invocations to, we link the Pinger to the Ponger. It is a unidirectional thing, so the Pinger is able to call the Ponger, but not vice versa. And that is going to be on in a WIT namespace and package called wasmCloud testing with two interfaces called ping pong and busybox. So I'll talk about these a little bit more and we'll come back and look at this as well. But then all that happens from there is we send an invocation to essentially call this first component. So that is the test, and we get some output back, but all of that is a little bit less useful without taking a look at what the component looks like. So if you want to, actually, let's look at the width that I designed. It's pretty fun to take a look at this. So I have a single width called wasmCloud testing. All of the names here are trying to be descriptive, but if you see the words wasmCloud or WRPC or anything like that in these widths, it's not like a hard-coded thing or a requirement. You can call them whatever you want. I have a couple of different interfaces in this WIT file. One is called invoke. It's a very simple, you can call this function on a component and it'll give you back a string. It's kind of similar to like a, just run it. We have a ping pong interface, which is designed for one component to import the ping function and another component to export the ping function. So you can ping a component and get back a pong. And then I've got a nice little busy box set of interfaces here where we can show different data types essentially being transmit over WRPC. So this one sends a number, gets back a number. This one sends a string and a character and expects to get a split list of strings from that. We've got a variant, so showing off some enum functionality and sending that over a function. And then last but not least, the thing that I feel like you always have to sneak in, a dog record, which this is like a struct or a class, and then a function to ask if that dog is a good boy. It's infallible, it should always return true. So if we take a look at the actual component itself, so this is just an interface with a bunch of declared functions. I'm talking about it from the lens of WRPC, but if we step up a level and just talk about components, that kind of puts us at the right level for the developer experience here. So I have a pinger component, and what that does is it imports the interfaces for ping pong and busybox. So all of these functions I'm going to import and make usable at runtime. And then I'll export this function or this interface invoke, which is the call function. And if you look at the code, this is what it actually looks like to write this component. So again, this wasmCloud testing or wasmCloud testing here is just the name of the package and the namespace. It's nothing wasmCloud specific. What I have to do is implement this one function call here for wasmCloud testing invoke. That's implementing that interface. If I didn't, actually have it in a different window. Rust Analyzer is fun. If I didn't, then I will get this error saying, hey, you need to implement this function call because you said you were going to export it. So that's pretty cool. Let me uncomment that. I am essentially just going through in the process of this call, this function call. I'm going to invoke the function on ping pong, which is ping. And then on busybox, I'm going to increment a number, split a string, make sure that this variant is the same, this like A equals A. And then I've defined a doggo, which is my dog Archie, and I will ask if he is a good boy. And then I'm just going to return all that information in this one fat string. But when we actually take a look at this actor, the pinger component, we run wash build. The component that we get, if we take a look at the width of this component, we can see that it is a single component, and the root world of this imports my two interfaces, wasmCloud testing ping pong and wasmCloud testing busybox, and it exports my one interface, wasmCloud testing invoke. So this is essentially, the same as my WIT as it is defined here with the extra things for WASI Preview 2. Those kind of things come with adapting the component. But when you do this, this component is now defined this set of imports and exports that it needs in order to get its work done. So whatever host you run this on has to give you a function for wasmCloud testing ping pong, testing busybox, and it has to invoke this function wasmCloud testing invoke. Now, this is actually really hard to do for custom interfaces to know all of these things. People who are writing wasmCloud components could use any number of interfaces. We don't know what they're going to be. And so that is why to two things exist. The first thing is composing components. So you may have seen this before when it comes to, you may have seen this before just in the context of WebAssembly components, where if one component has an import, you can create a component with that export and then compose them together so that when one component calls the wasmCloud testing ping pong ping function, it's actually invoking that other component directly, but they are fused together to be one single component. That other side of the contract is implemented here in the Ponger component. Let me open this up side by side. Go away. So if you look at the, oh, I don't want that. Go over here. Yeah, if you look at the pinger component, it has an import for wasmCloud testing ping pong. If you look at the ponger component, it has an export for wasmCloud testing ping pong. So it's the different ends of the function. And when you when you compose them together, you would link these functions together and then they would talk to each other. The whole goal of WRPC is that when you do this, you don't have to compose these components together at essentially compile time and then run the compose component. You can run both of those components and then connect them over the lattice using WRPC. So both of these components, instead of directly connecting them, you can link them together at runtime with our regular wasmCloud functionality. So I did talk a little bit about it, but I do have a Ponger component as well. If we build this component, we can inspect the width. I meant to say this a little bit. Come on, give me the thing. I meant to say this a little bit earlier, but feel free to cut me off in this demo if folks have questions. If we take a look at the width of this Ponger component, we can see it imports logging, which is just, I'm going to log a message, and it exports the two functions that my other component is going to import. Okay, so the way that it works is if I take a look at I'm going to go back and take a look at my test again. Essentially what we're going to do, since Pinger is going to be importing ping pong and busybox, and Ponger is going to be exporting those, we are going to link those components together. And this function is in the test utility, but we're just publishing a link between those two. And I can run this test, which will start the two actors, start the two actor components, link them together. I might just get a pretty anticlimactic pass from this. Yay, it passed. Okay, but what this means is that the result of all of this is I received this function, or I received this value, ping pong. The meaning of the universe is 42. We split my string. Hi there, friend. My enum was the same, and Archie is a good boy. And if you look, all of these functions essentially, this is all an interpolated string of all of the things. Now I want to show one more piece of this, just to show you like kind of the flow of how this is working. I'm going to hack this together a little bit, connect to Nats URL. I want to show the actual flow of traffic. And because I'm not infinitely fast, we're gonna put a sleep in here. What I'm going to do is do a NAT subscription on localhost, and then it's gonna be on default.star.wrpc.caret, whatever. Essentially the topic that all of these WRPC function calls are going across. Because each time you call a function on another component, we're sending a NATS request to that component to call the exported function. So I just need to know the random port that we get from this, which is, uh-oh, give it to me. Where? No. Oh. Oh, I'm done. I printed it after I slept. Okay, 1 second. Okay. So if we take a look, when we start up these components and they invoke each other, what we do, oh, this is just that. I'm going to listen to everything then. So I didn't plan this part of the demo. I just wanted to show the cool stuff. So let me just subscribe on everything. So we'll send a couple pieces of information to like start the component itself and then link it. Then when we actually do the invocation, we can see that starting from here, we'll say, hey, I want to invoke this component on this very specific function. We're going to call the wasmCloud testing invoke.call function with the body, which is nothing. We didn't need anything to invoke this function. That component is going to call the Ponger components wasmCloud testing ping pong ping function. And then the results that you get back from that individual function is Pong. Then we're going to turn around and call the wasmCloud testing increment number. The result that you get back is encoded here, but we as a whatever UTF-8 thing, but we get back 42. We're going to call the string split function, and then we get back the payload of hi there friends separated by or we send the payload hi there friend separated by commas, and then we get back the result, which this is the vec. Same with A, same with sending the information for Archie. And then finally, we send back the information with the final payload. So there's a little bit of a lower level look into what is actually happening on how this works. But the key point to get away from this demo is that instead of running well, let me see if I can do it in time. Instead of running a Wasm Tools component compose, where you stitch these components together, their imports and exports together at compile time, with wasmCloud, now whenever you run a component that has an import or an export that is not satisfied by wasmCloud, you can hook it up to you can link it to another component at runtime, and you'll be able to invoke that component without needing to do anything extra to your component to make it work. I won't try to handcraft this anymore, as I've already tried to mess with subscribing to Nats for maybe 5 minutes, but I'll take a pause. Do folks have any questions or things that they wanted me to dive into here on WRPC?
Yeah, so Brooks, I think you mentioned this in Slack, and I don't exactly recall what you said, but if the actors are on the same host, is everything still sent over NATs, or is there some sort of short circuit?
Yeah, so right now, even if the actors are on the same host, they are still sent over NATs. Because the functions are so strongly typed, and essentially here we're just doing a little local loopback. It's a little bit easier now for us to find the target of the invocation and then call the function. So I networking being one of our biggest possible bottlenecks in wasmCloud, I can definitely see us adding a post 1.0 feature where we can optionally invoke locally if available.
And okay, and I know that this is, I don't want to say preview 3 anymore, because I don't think we're supposed to say preview anymore. I don't know. I'm always the worst with shibboleths. The next version of Wasm Time, I think there's the idea of adding this in. Something similar. Obviously not WRPC, but having kind of dynamic runtime gluing of components together. Is that? I don't know. Is Bailey here? But I don't know. Is like this will have to kind of work with that, I would imagine, at some point, right?
Yeah, I know that for P3 or at some point, I think it's this year. I'm not going to commit any hard deadline. The Bytecode Alliance folks have talked pretty extensively about what they're calling host components, which is a pretty similar implementation, like to the way that we do capability providers. Basically,
Right.
running some kind of code that's not a component, but extending the security model to it. Um, that is still something that I don't completely understand all of the way. Like you said, Bailey could probably explain a little bit more. But yes, exactly. I think that the goal is just to support that
Yeah.
as it comes out.
I think ideally if there was some sort of, I don't know, something thrown like, hey, that component doesn't exist here within WASM times. I mean, the whole thing is we have to make a WASM time scheduler. That's actually a real scheduler now. Well, whatever. Something like a real scheduler now, especially with that async work. Um, I don't know if there's going to be some sort of like way you can look look for the component, not find the component, and then send it over to WRPC. I don't know. I don't know where you'd fit in with that. This is cool.
Yeah, yeah, it really, I feel like it gives a really good foundation for for application runtimes to like build on top of WASM time, and so uh, depending on how that looks, like we would just make use of that abstraction instead of the capability provider abstraction um, in that kind of world.
Yeah, no, that's really cool. But this is great. I mean, I think it's really great, especially for for. I mean, it's great for components, but it's great for actors. But it's really great for providers too, because you're definitely not going to have every provider running on every host. I mean, just if we think about how wasmCloud we want, something next to a database in AWS, say, and something else somewhere else, you need that. Um, you need this in the new WIT world. You need something like this, right?
Yeah,
I think
yeah,
I got that right.
yeah. This is something that we exist in a somewhat middle ground area right now. I don't know why. I'm going to show something in a second, but I'll stop for now. We exist in a little bit of a middle ground right now where the way that we have done things for so long with WASM cloud contracts and like invocations over WASM bus is something that we couldn't implement all the way with just components and NATs, but WRPC is kind of that missing piece where now when you write a component, you can just write a component, and then when you run it in Wasm Cloud, we set up all the right subscriptions for you, and the component is just calling imports as it normally would.
Yeah.
I don't know if I actually, okay, I have a few things to, Yordis, I see your hand is up. I just wanted to share a couple of things. I wanted to show, so like what this really looks like. I'm calling ping pong ping. I'm just saying it to make Kevin laugh on the other end, but that's coming from the generated code from Wasm Cloud testing. If we wanted to look at the Ponger component, I don't remember if I showed this code, but the implementation on that side is simply implementing the function ping by returning pong here. So the on one end is us importing the function and calling it within the code in order to make your business logic work. On the implementation side, this will be, you can think of this like the provider. In this case, I'm doing the actor. We will have the actual implementation here. So this is exactly how components are going to communicate with capability providers as well. So inside of your code, and this won't work because I don't have it imported. Nice job, GitHub Copilot. You would say something like my number equals WASI or WASI key value. I think it's eventual increment, 41. This would create an import. You do it in your WIT. You'd have an import for WASI key value, the eventual. And then on the provider side, we would have a function called increments with a number and so on and so on. I hope I'm nailing this part of the point pretty well, that like we have one side or
Yeah.
like an import and export side.
Didn't Dan added something to a README or something around providers with WIT? think.
Okay.
I'm just talking. People are actually typing like they're supposed to be. Sorry.
No, it's fine. Um, oh, while you look that up, what I wanted to show, so I'm running the test right now, but kind of in this end state, and I'm gonna rest for 10,000 seconds or whatever, because I wanted to actually, I'm going pretty bare bones here. We're using Nat's requests to make requests to the control interface, but I think this will be pretty fun and illustrative for the new control interface topics. And to take a look at like what data is actually coming out of it. Thank you, Apple, for giving me the thumbs up. So if we do wasmbus.ctl dot default, which is the lattice name, host.ping, we can actually get the hosts that are running. So I'll take this ID, and I promise I'll use JSON output for the rest of it. We can get what's running on this host. Which if you haven't seen the formalized control interface thing, all of our control interface topics are organized with a prefix, the lattice name, and then noun and verb, which is super nice. So right now, the way that this works, sorry about that, I have two actors that are running, the pinger and the ponger, both of them just from like kind of the debug test build thing. They have a name, they have a max concurrency, or max instances of 5. But the way this actually works is it has an ID specified called WRPC pinger component and an ID WRPC ponger component. And if we do one more query and we take a look at the links that we have in this lattice now, we have just one. This is the new, I call them interface link definitions. They're unidirectional, but this pinger can target the ponger on the WIT package wasmCloud testing in the interfaces ping pong and busybox, which are the two that we've kind of set up. So there's two things that I want to mention. One is that you get really, really fine-grained control over these interfaces. You can link one interface to a component. You can link a different interface in the same package to a different component. The target here is an ID. It is the target here is can be a unique ID. It can also be essentially a name of a group of things to invoke. I'm gonna pull myself out of this rabbit hole because that's gonna be weird to explain. But post 1.0 feature that will be coming, and what you can actually do is data default. If you want to take a look at the information that we have stored for this component in the lattice data bucket, this is actually where we, people may not know, but we use NATs for all of our RPC layer and for the control interface APIs, but we also store things in Jetstream so that every single host can access them. We have actually information on this individual component stored in the lattice data bucket, like the links that it has, the URL that it came with. And we'll probably extend this to also include stuff like a hash of the bytes so that when you start a component with this ID, you can assert that it's the right hash, et cetera, et cetera. This is kind of a background look into some of the stuff that we've put into place in order to make this happen. So any host that starts up in this lattice will have information specifically on what the pinger component is able to, how it can invoke things. I'm going to check one more thing to make sure I actually hit what I wanted. Slight aside that I found the code autocomplete to be really great when I was working on this example yesterday and today. If you want to see an example of this, if I remove the increment number function, I get an error saying that I haven't implemented the increment number function. And you can just use like VS Code autocomplete. It comes with the documentation that is in the WIT, and I can implement it, and everything is all well and good. So expect some updated developer iteration loop type guides for how to build components, which kind of varies based on what language you're doing. Okay, Yordis, I'm sure your arm is tired at this point. Thank you for hanging out for a bit as I went on my asides.
Yeah, so I have two questions. The first one is like, what are the implications around the capability provider architecture and stuff like that that you have today? Like, you know, how that relates to these changes in for the future of wasmCloud and how we should be thinking about this moving forward. And the second thing is, I'm not sure if this is true, but it seems that the width file will become the specification of my messages, right? Would I use the width file in order to uh, marshal or whatever you call it to send a specific message payload? Like, how does that work?
Yeah, so I'll answer your question in reverse order because it's how my brain is organizing it. The WIT file you can use to describe all of your types, your structures, your functions, like what you're planning to invoke or you're implementing, so that other components can invoke. But it's completely agnostic to the protocol or the marshaling or the transmission format. That part is still handled opaquely to the component developer. Um, I think I could see a world where you would want a little more customizability there, and we could build that into wasmCloud. Um, the really important thing for me is that you can just take a straight up component and run it in wasmCloud and then be able to compose it in a distributed way. Um, and then to answer your second question, we've actually gotten quite a few questions in the wasmCloud Slack over the last few weeks about, especially over the last week, about people building their own custom capability providers and asking if they should be doing it in Smithy or if they should be doing it in WIT, and asking what this new provider SDK thing is. So I just want to say, first of all, that I really appreciate everybody's patience who's looking to toy around and implement a capability provider right now. We do have a pretty sweet new provider SDK that's not documented. And we have a pretty sweet new WIT bindgen macro that's only a little bit documented. And so when it comes to implications for capability providers, it's less change than you may think. So if you look at a current, if we take a look at the NATS capability provider inside of the wasmCloud repo today, it is actually using this WIT in order to generate its structures and types and to some degree function handlers to be a capability provider. So we import and export two different interfaces from the wasmCloud messaging WIT. If we take a look at the actual messaging WIT, you'll see similar things to the Smithy structures, like this is a message, and the functions you can import are publish and request. So the good news there is that building a provider using WIT, you're kind of already doing that. And in the actual capability provider itself, if I look at publish, implementing this function is very similar to a component where you implement a function for the trait, which is wasmCloud messaging. This is kind of auto-generated. So ideally, and I don't think it'll be exactly this case, but ideally, these capability providers that we have are already using a WIT bindgen like macro to generate structures. They're already implementing functions that are not, they don't appear to be tightly tied to WASMBus RPC. And so the end result is the same thing, just with WRPC subscriptions and invocation handlers at the end of the day. So a provider isn't going to need to change very much once it's using this new SDK. And the real call out for us here, I think, is to provide more documentation around the provider SDK itself. We do have pretty decent information around the WIT-bindgen crate and the WIT-bindgen macro that you could take a look at under our crates directory, but I'm going off on a little bit of a tangent here. Jordas, is that getting at the core of your question?
It's good. Thank you.
Hey, yeah, go ahead. Good to see you,
Yeah,
Jochen.
thank you for pointing that out. That was one of the questions I had this in the Slack channel, right? I'm was dabbling quite a bit in the actor space, but now dabbling in the Nets key value capability provider space, so which is a little bit new and changing, as you said, and thank you for pointing that out. But for me, it gets more and more blurry between provider and actually a component, because everything is kind of is a provider is nothing else than for me now as a special case of a component that has kind of a side effect, more or less, to the outside world. So what's your kind of take on that, how that all evolves now?
I've got a fun take, but Taylor threw his hand up first, so I'll let him go and
I
maybe
got
we'll
a
cover the
take
same stuff.
too. Anyway, so no, that's a great question. So the way that I look at, actually, Kevin also said a good one too. An actor's a privileged provider, or a provider is a privileged actor. The way that I've always been explaining this is one is stateless and one is stateful, and it is like it's basically exactly what you said. It's something that can have side effects, right? Is the more like technical term. Um, so that is what you like. What you're saying is 100% on board with like where we're going. That's why host components, what they're calling it in like the WASM time space, is essentially it's a provider. It's a thing that can hold state and is long running that way. But it's that's really the difference. So if people like get into the nuance there, that is the big difference between the two. Is one can hold state and one does not hold state.
State in memory,
Okay.
state in KV, states where? And I'm just playing devil's advocate here to be precise.
I'm
Yeah.
talking about stateful things like connection pools, like those kind of things, not necessarily like a database of some sort. Though they're often used to connect to databases. It's talking about things where you have a set of things that is generated and can be long-lived. Another common thing we see a lot in the WebAssembly in wasmCloud in particular is like machine learning models. Those you don't want to have to load every single time, so you generally put those in a provider.
So we know there's a lot of changes coming, with 1.0. The big two being, some of the language constructs here. So we're working on a new WASM Cloud, how does it work, landing page, and some new artwork here to sort of take you through it conceptually. So, as you called out, the big news, with what we've been referring to as actors is they're just WebAssembly components now. Nothing needs to be done. Standard WebAssembly components, start, stop, run. And we had toyed around with still calling them actor components because we are still closely aligned with that model. But I think for simplicity and explanation, the images where we're landing is that these images will end up as just saying that they are just WebAssembly components, just to help explain it easier. So this difference between capability providers and WebAssembly components. The first thing is when we're thinking about the imports of a WebAssembly component, there are 4 different ways that they can be satisfied. So a WebAssembly component can have its import satisfied by the host, the runtime itself, which does include a number of secure capabilities within the trusted compute base. So common things like clocks, HTTP, and a few other things. It can also leverage other WebAssembly components locally. It could use an external provider, which is where we're talking about now. So this is outside of the core wasmCloud process, and the advantage to this are multifold. Being
Hey, Liam.
outside, yeah, go ahead.
Would you mind? I just want to make sure that we are addressing and getting to like Johan's question. Um, the original question was around providers, right?
Yeah, that's what I'm getting to. On the providers here, being outside, you can hold state, things that would be longer lived. So connection pools, think like database drivers would be the idea. So these would be stateless when we're thinking about WebAssembly components. And these would be more stateful kinds of things that you would want to be interfacing with things that are holding state would be a way you could do it, but they could hold state themselves. And then or you could mount and satisfy those capability providers remotely using WRPC, which is what Brooks is demonstrating here on a remote host. And Brooks, thank you. I know that I was kind of trying to answer the question a little more broadly here about how you can satisfy imports. But I wanted to make sure that we sort of teased that out a little bit here and made sure that we included the sort of broader explanation. Did that answer your question?
Yeah, absolutely.
Right. And I think this new doc we're working on will be a big help because we're trying to just explain this in clear English. Our goal is to have this out, in the next week or so. Certainly when we have a release candidate out in time for wasm.io. So we'll have this out, and there's a whole bunch of new infographics that are coming here to help drive and explain all the mechanics here of links and the different objects and all that kind of stuff. And we've just been iterating through the language over and over again to try to simplify this explanation.
Can I ask a quick follow-up question? I don't know. So a privileged actor is a good point. One of the things that we were looking into were kind of how do we store credentials or secret information in a link, right? Right now, it's pretty much clear text, and it's a little bit uncomfortable to store it there, like to Redis or to Postgres database or to Nets itself, right? Was there any discussion further than a few months back that we had the discussion first?
Okay, so yes, and we have some developments there. I think your base concern isn't quite alleviated yet. And Taylor can always jump in here because this is kind of the thing that he's pushing forward. But I wanted to talk about how when we put a link definition now, you actually aren't putting the full map of all of the configuration, which may or may not include secrets, for example, as a part of that link definition. You're linking a source to a target. And you're providing a list of names for configuration that the source or the target may need. Now we've got some ways to simplify this, but the big point of this being a name is that we're actually going to pull this configuration from an external location in order to hand it to the component or to the provider. I'm just going to say component. You can assume that means both. Part of the reason for this design was more flexible, reusable configuration. But another big part is that we may not always want to be storing this type of information in Jetstream, which is what we'll start with that because we already have all that. But we may want to pull configuration maps from Kubernetes to satisfy a component link. You may want to pull configuration from a secret store and hand it to the component at runtime and not have it stored in Jetstream, for example. So that's exactly what we're thinking about when we're making this API change. The tooling will probably still look similar for us. Like you're not gonna have to, we'll have an easy way of defining and creating and associating config, for example. But that's kind of exactly what we're thinking about with this change. Taylor, did you want to add anything else onto that?
Yeah, the thing is right now there's plans in the future, not before 1.0, to like be able to tie in things like Vault or something else, like some sort of external integration point for those kind of secret providers. But right now, with this change, you can store it in like because you can do encryption and stuff across the wire and everything if you want to inside of NATs. It's going to store it inside of NATs KV when you give it config. So at least now it's detached from the link itself. So it's not, you can give a user access to do the control topics for links, but not for config, for example. They could put config but not read config or something along those lines, and then control it that way. And so we figured that was enough to get people started, and then we're going to kind of amp up the secret integration from there, depending on what people need from us.
Yeah, excellent first step, I would say. That's decoupling it. Excellent. Yeah, that's actually enough for the production start, so to speak. Yeah.
Awesome. Glad to hear it. Yeah, we know that's something that we need to bring it'll certainly land, or like robust pluggable secret provider and everything will land post 1.0. But that's exactly the kind of stuff we're thinking about now.
Thanks.
All right, folks. Really awesome questions. I'm going to go ahead real quick and just take care of the remaining agenda items, just so we don't lose track of them, which is just a check-in on the WRPC milestone, and then on the MVP milestone, and then on the roadmap. I apologize. I'm essentially finding all of this stuff through GitHub, but that's how you can find it too. There's an issue that we have around WRPC MVP integration, which is, it has me and Victor assigned, but many of us are doing work towards this. We are tracking a couple of issues and checkboxes that come up in our PRs here. And I have tried to give a high-level update yesterday based off of what the work that we've done, what's in progress, and what we have to do in order to merge this WRPC branch into main. We talked a little bit about the success criteria here, but in this community call, you saw the MVP of components talking to each other, imports and exports, working great. We want to integrate well-known WASI contracts. So like the way that I'm using this test to call this function, I want to be able to do that, but with curling and endpoint for WASI HTTP, and have providers, of course, on each end, so that you can implement your the same wasmCloud functionality. But that is essentially the what's kind of captured here in this to-do list. If there's anything that comes up that's a good first issue, I will definitely let you all know. I have just been a little bit cautious about that because the Feat WRPC branch has gone through 1 or 2 changes over the last week and a half since we opened it up. So I'm advocating caution around contributing to this, at least to this branch right now, because so many things are changing so quickly. So keep an eye out on this issue for how our progress is going. I'm sure I'll have more and more of a demo next week. But once we can get the functionality implemented and then tested is the other big part, which is why we're trying to start with some good integration tests. We can start cutting alpha and release candidate versions of 1.0, which is really exciting. And okay, any questions on that part before we move to the roadmap update? Sweet. Taking a look at the roadmap for 1.0, we have moved a ton of things out of blocked and in progress because we've completed them. So a ton of work is completed for the 1.0 milestone. You can see that the name of the game of what we have in progress is getting WRPC integrated, working, all of those things. What is essentially next and ready for work comes with working on removing some of the claims signing, for example, because we don't need wasmCloud capabilities anymore. It's all assertable with WIT, or it's all discernible with WIT imports and exports, and all of those things need to be linked together at runtime to talk to each other. So there's still the access control, the routing, and the configuration. This one is ready for work and is actually a good first issue around dropping the wasmBus EVT lattice ID subject. We publish on wasmBus EVT lattice ID and then event name now, and all of our tools essentially have been updated to use the new, or have had enough time to update to use the new version. So we can drop the subject, and that one is ready for work. Other than that, things are still a little bit in discussion. This one must be a broken record at this point. We're just waiting until we essentially get to 1.0 release candidates before we version our WITs at 1.0. Adding additional features for labels or additional events for labels was a real nice to have, but would be good for like WADM and reconciliation, and then just a few more that we need to really hammer out what we want to do before 1.0. But we're getting really close, making great progress to the 1.0 milestone. So hats off to everybody who has been working on this really hard. Okay, I just wanted to make sure that we did that because we were having some really awesome discussion and I didn't want to forget about it. But we have about 5 minutes left. Do other folks have questions or topics they wanted to bring up with WRPC, wasmCloud, WebAssembly ecosystem in general? All right, y'all. Well, great community meeting today. Thank you so much for coming. Looking at next week, I'm going to try to do WRPC demo V2, but if anyone else is working on things in wasmCloud world and wants to sign up for a demo, please let me know. Same thing for discussion items. We can always throw it on the agenda for next week. But until then, thanks everybody for coming. Go ahead and stop the live